it later. But I'll turn it over to Shapur, I guess, and Jesse, if you can give us a quick introduction about yourselves and proceed.
Yeah, absolutely. I can kind of kick us off here. Again, thanks for joining. If you had joined the other sessions, we mainly focused on mapping, kind of a demonstration of mapping in TermWorks and Term Manager, specifically in the tools that are hosted by Infoway. While those other sessions focused mainly on the functionality behind the tooling, today we're going to shift our focus on the mapping process, including some best practices and tips and tricks there that will help you get the most out of these tools. And we'll also look at some examples of these within Term Manager as well. If you don't know me already, I've been with Apelon for 7 years. My name is Jessica Boda, and I'm the manager of content and product services here. And with that, I'll pass the ball over to Shapur.
All right, great. Thanks, Anil and Jess. Good morning, everyone. So Anil, I'm trying to share my screen here, and it says...
okay, let me make you the host so that you can go ahead and do that.
All right, and Anil, are the participants able to unmute themselves if they have questions?
Yep, they should be able to unmute themselves.
Perfect.
Please feel free to ask questions throughout the presentation.
All right, thank you. So hopefully everyone can see my screen here. Before I start, I just wanted to say hi. I see several familiar names, and it's nice to connect. One other thing I wanted to mention before I start is just set expectations here with respect to the presentation that I'm about to have and their scope. So in terms of the audience, I think this may be more suitable to our audience that is a little towards maybe beginner, intermediate, and not so much towards the advanced mappers. There are, at the end of the presentation, there are going to be a few tips that even advanced mappers might find useful, but for the most part, it's designed for beginner to intermediate kind of user. So I just wanted to set that expectation. And with that, let's just start. So I'm going to start from the very beginning. A lot of people in my experience have different meanings in mind when we say mapping. So I just wanted to be super clear and say what that means. So basically what a map is the relationship between a source terminology and a target terminology. So the source is typically something that the users would have in their local environment. So it might be their local code set, local pick list, whatever the case might be. The target, again, not always, but typically is going to be a standard terminology. So it could be, for example, a SNOMED CT or LOINC and so on. The goal of the map is to find relationships or associations, or basically draw arrows from these source terms into target terms. So basically for each one of these source terms, we want to find the best target term that would match. The goal again is to map everything. Sometimes it might be the case that some terms may not map for a variety of different reasons. Sometimes it's just very vague and ambiguous, and we don't know exactly what that means. Sometimes it's very specific, we cannot find in the target, and we'll see some of the examples later on. But again, the goal is to map everything. In terms of the arrows, if you imagine arrows going out from the source, going into the target, obviously for the target, you cannot expect that everything is mapped to, meaning everything is used. For a SNOMED, for example, you have 300,000-400,000 concepts, and you wouldn't expect to use everything. And one other thing to mention is, again, this is typical, not always, but usually for a mapping exercise, we try to map one source to one target only. So meaning one arrow goes out. If you look from the target perspective, one target term might be the target of multiple source terms, and that's absolutely acceptable. So multiple sources could go into one target, but usually what we try to do is go out only once from each given source term. So with that in mind, let's continue. So again, I'm going to walk you through some of the thought process that I, for example, or some of my colleagues would have when we want to start a mapping project. And some of the things that we consider, some of the difficulties that we face, and how do we resolve them. So before we start, we want to have a few things clarified. We want to understand the source vocabulary as much as we can. We want to know what its purpose is. We want to know how it was developed. We want to know how it's used or displayed, and basically anything about the use case. One thing to note is at Apelon, we do mapping as projects for other organizations, and so we are not intimately familiar with the data, with the source data, obviously. Sometimes it might be the case that you want to do mapping for your own organization and you're intimately familiar already, so you're one step ahead of the game in that regard. But what we want to do is to know exactly what's happening with the data. And there is always, at least in my experience, something that we learn later on, and it's a surprise, and we would say, you know, I wish I knew that before, and this would have helped. In one particular example, just to tell you, we later on realized that the source, the way the source is organized, is that a bunch of different terms are actually mapped behind the scenes, and that mapping was not delivered to us, to each other. And that would have made things a lot easier if we knew that from the beginning. It would have made things a lot faster too. So again, everything about the data in the source, I want to know before I start. And we ask questions, we probe, and we try our best to understand the data. We also want to know if there is any information model inherent in the data. I have a slide later on to just talk very briefly about what I mean by information model. The last two things I want to know is about the maintenance. So a map will have to be developed. It's a lot of work, yes, but at the end of the day, it's not going to stop. You would have to maintain it, especially since target terminologies typically undergo maintenance and updates. So in case of SNOMED, for example, it is updated every 2 years. And so for that reason, you want to maintain your map, and you want to think about it from the beginning. You want to have a plan of action in mind before you start it. And so very important would be how the local code sets are also being maintained or updated. So one quick slide on what I mean by information model. So information model, you can think of it of different sections that you would have in a traditional patient chart, right? So for example, in a patient chart, you would have discharge diagnosis, you would have family history, you would have a bunch of other different areas. So now if you imagine a term called diabetes, and you put that term under discharge diagnosis, basically what you're implying here is that patient has diabetes. Without saying that the patient has diabetes, that's what you're saying. If you put that under family history, then what you're saying here is that the patient has family history of diabetes. So this is important for the context. When we work with data that has some inherent information model, we want to consider the context. So we want to, for example, map the diagnoses with diagnosis in mind, with conditions in mind. We want to map family histories, with family history in mind. So they may most likely go into, if you're talking about SNOMED, they should go into situations and so on. I'll have some examples later on. So the other thing we want to do before we start is also understand the reason for the map. Why are we trying to map anyway? So the reason, the users who will be using the map, who are the users, and how will they use the map? This is also very important, and this is also the use case about the map and about the end result. We had this example a little while ago, and I think this is very interesting. So we had a client with a number of source terms. They wanted to map, so they had a number of derived terms, and they wanted to map. When we asked why do you want to map and how it's going to be used, they told us that this is going to be used for allergies. So they wanted to consider drugs as allergens, and they wanted to document what patient has allergy to what drug. And so what is interesting about that use case is that if you consider that use case, the dose and strength, and even in some cases the route of the drug doesn't really matter. So for example, if you're thinking about Advil, and a patient has allergy to Advil, it doesn't matter if you have a 200 milligram Advil pill or a 400 milligram Advil pill. The patient still has allergy. You as a doctor, you still don't want to prescribe it. So when that's the reason, then what we suggested was, okay, then let's focus on the ingredients. And the other thing we suggested was, let's also focus on the brand name, because so again, example of Advil, the ingredient, the active ingredient in Advil is ibuprofen, and yes, you would want to avoid ibuprofen for patients, but we also know this for a fact that some patients have allergy to Advil, but they don't have allergy to ibuprofen. So it's also important to note what brand name has caused the allergy to try and avoid it, especially. Now, put that side by side with another use case, that is using drugs for prescription. So obviously for this latter use case, you would want to be very specific about the dose, about the route, about the dose form, and everything. So again, when you consider the reasoning and the use cases behind it, it helps you tremendously with how you would want to map, and when you can compromise and when you cannot compromise. Moving forward, the third thing we do before we start the mapping is we want to decide on what target terminology we want to use. It largely depends on the domain, of course. So for example, if you have drugs, you don't want to try to map it to LOINC. LOINC would be more suitable for lab. You may want to consider either RX norm in the US, or you may want to consider SNOMED, or other more drug-specific vocabularies. You also want to consider interoperability. So what I mean by that is one of the main reasons for doing the map anyway is to achieve interoperability and to be able to share your data with other organizations and be able to compare, benchmark, do things like this. So if that's the case, and if there is a specific organization or maybe a sister company, for example, a sister organization, or even national, provincial requirements, then we want to consider that in order to choose our terminology. So if everyone else is using SNOMED, it's wise to use a SNOMED. Even though we might be able to map to other terminologies, you know, if other people with whom we want to share our data is using the same SNOMED terminology, then maybe that's the best thing to do. Use cases are also important. So for example, when people want to do analytics with their data, it would be a good idea to use a terminology that supports it. So again, SNOMED with the description logic that it has, and you know, the ontology relationships that it has, would be a very good candidate for doing analytics. Another thing to consider is whether we want to have one target or multiple targets, and that's sometimes a good thing to do. So when we have a client with a large amount of data, their data coming from different departments, having different use cases, you know, everything that we discussed so far. Sometimes we, depending on the data, depending on the use case, sometimes we suggest to them to use multiple target terminology. That would make things more targeted. That would make things sometimes easier to map, and you know, we don't want to lose too much data when we map, and we'll see some examples later on. So we should choose target terminology very carefully. All right, so before I move forward, I wanted to ask, is there any questions so far? Okay, hearing none, I'll continue. Please feel free to stop me if you have any comments or questions. All right, the next thing we want to do is considerations around data processing. So what we want to do is we want to preserve the source data as it was delivered. Source data usually comes with more than a couple of columns. Sometimes it comes with multiple attributes that are associated with the data. And that is something to consider. Sometimes the attributes are important. And how do we deal with them? Depending on the tool that we use, and I'm assuming Jess has talked to you about the tools that we have, and you know what they can do and what they cannot. You know, that might be one of the considerations. There is also usually the mapping projects that I have been involved in, there is always some duplicate. So data might be coming from different systems, different databases, and they end up being duplicates sometimes. We want to remove those duplicates in order to make the file more manageable and basically reduce the amount of effort that we want to have. Sometimes data has heavy use of abbreviations and acronyms. Those should be expanded as much as we can, especially if you're using automated mechanisms to map. It's very important. Sometimes the software is not able to pick up the abbreviations and acronyms, and it would be much easier to expand them. Then there is a little bit of cleanup involved. So we go through data, we identify some of the opportunities for cleaning, such as different spellings, for example. If there is extra spaces, we want to remove them. Unwanted characters, we want to remove them, things like that. Then we want to prepare our data for import. So into our tool. So in this case, if you're using DTS, then that would be your tool. You know, TermWorks, Term Manager. Again, I'm assuming Jess has talked to you about those, so I'll skip this. This is an example of some source data, and you can see there are a number of different columns in here. This is actually data that has very few columns compared to other data that you have received before. And as you can see, it has a column that is called mnemonic. It has a column that is the type. It has a column that looks like the type of the lab exam, lab test, which is also very important in LOINC. You know, you do have classes for this. The active status may not be much important. Then there is catalog name. So one thing we need to do is decide which one is the ID. So maybe this one, which one is the name? Should we choose the mnemonic or should we choose the name? And then whatever we decide as the name, then what do we do with the rest of the column? Again, you know, this column looks important if you're mapping to LOINC especially. If you are mapping it manually as a human, this is something that is very useful. If you are mapping it automatically, then it's also important to note that adding more information may not necessarily be a good idea because the software gets confused. So again, things to consider. There is not really a single recipe to all that, but it's just we do that on a case-by-case basis. We decide based on all the parameters that are involved, everything that we see. Sometimes, yes, we do concatenate columns. Sometimes we just ignore them. And I think what I'm trying to emphasize here is try to understand the data as much as you can, and then decide how do you want to load it, and you know what would make your life a lot easier. You know, based on the columns that you choose and the cleanup that you do and all that. All right, so from here, what I want to do is go over some examples, and with these examples that I have, for each one I have a point. So for example, with these examples here, I want to point out the granularity concern. These would be some of the considerations and some of the challenges that you would face when you're mapping. And so through these examples, we can maybe find some good ways to deal with them. So Jess, I'm wondering if I should hand it over to you.
Yeah, I'll share the term manager tool, and I'll have these examples side by side so we can look through it together.
Okay, all right, that sounds good.
I think, Anil, you have to allow me to share now.
Oh, no, Shapur has the
Oh, okay.
host role, so he can.
Got it. Okay, so are you able to see term manager on the left and the slides on the right?
Yes.
Okay, great. All right, Shapur, you can lead us through the examples and I'll kind of follow along on the tool.
Okay, great, thank you. So just to double check here, are others also able to use the tool at this point, or is it just you, Jeff?
I believe others should have the ability to log in. I'm not sure if everyone has used it yet. InfoWay does provide access to TermWorks and Term Manager, but I'm not sure who on the call has it installed, at least on the TermWorks side.
All right, so for those of you who do have access to Term Manager, you may want to open it and follow this. If not, you can just watch Jess, and I'll talk over it. So the first term here that we want to map is the alcoholism. Jess, if you try to do that one, please.
I might need to log back in, sorry.
That's all right.
There we go.
All right, great, thank you. So the point I want to raise with this slide is granularity. So what happens when you're trying to map is that sometimes the source and the target have the same level of granularity. In this case, alcoholism in the source has an exact and perfect match in the target. Same term, alcoholism. It's a disorder, and you know, we can use that. We'll be very happy with that. It is the same granularity, so we are not losing any information. Now let's try to do the next one: coronary artery calcification seen on CT scan. Right. So this one, the first one on the top, the first choice on the top is probably the best one. Calcification of coronary artery. That's saying the same thing, same diagnosis, but there is another extra piece of information in the source, which is basically saying how it was diagnosed. So the method of diagnosis is also in the source, being CT scan. And when we map it to that particular target, then that piece of information will be lost. And that I just wanted to have these examples to show you that this is just sometimes the case. It's very often that in the source and in the target, you don't have the same level of granularity. And this would be a compromise that you may have to do. Generally speaking, when you map, you will lose data. And so that would be the disadvantage. The advantages of doing the map, the reasons behind doing the map should outweigh the disadvantages. And, you know, we'll talk about it a little more later on, but this is just something I wanted to highlight. So now let's do fracture of right hip. Okay, so the word right here, the laterality, is causing problems. If you remove that and just try fracture of hip, there is, right. So there is a number of different options here, and those would be good options for this term. Again, the point here is and this is very typical in SNOMED, with laterality, there are a lot of terms that do not have laterality. And in your source, you typically do have laterality because that's something that the clinicians document, and you know, it's important. So then again, one of those areas, if you do not want to post coordinate, and hopefully you guys know what post coordination is, then you just have to rely on what you have, which would be fracture of hip region or something like that. And again, you would be losing that laterality information. Let's do the next one.
A quick question. For this fracture of hip, you know, the score on the right-hand side, you see the score concept name. The first one seemed to be neck. I would think fracture of hip might be higher. How is that determined?
So what Term Manager is really great at is searching among synonyms. So right now we're looking at the concept details for fracture of neck of femur. And you'll notice that in SNOMED, they have a synonym of fracture of hip. So it is an exact match, even though it's not matching on the fully specified name, if that makes sense.
Yeah, that makes sense. Okay, thank you.
Great question. All right. So let's look at meningioma. Okay, so we don't see a good match here for meningioma. But Jess, could you please try searching for benign meningioma? Right. Okay. So there is a term, benign meningioma, and we could map it to that one. Now, let's just say we want to map it to that one. And now compare it to the other two that we had above, the other two examples, coronary artery calcification and fracture of hip. With coronary artery calcification, as you saw, we lost information. Same was true with the fracture of hip. We lost information. So what we call that is a narrower to broader map. So you have a term that is narrower, you have a target that is broader, has basically less information. And in mapping, generally speaking, that is acceptable. If you don't find something at the right level, basically narrower to broader is perfectly acceptable. The other way around, so broader to narrower, is usually discouraged and is not a good idea typically, because you're adding information to the term, and that information may not necessarily be true. However, sometimes it's just a case that we call it implied clinical information. And so sometimes when the clinician looks at the term, they would say, oh yeah, this is basically what that means. And so it's implied clinical knowledge. Clinicians would know it. Mappers who have some clinical knowledge may know it. Sometimes we have to take it back to the source organization, find clinicians who might be able to answer the questions and just check with them. So again, this is something I wanted to show you as examples of maps that are at the same level, maps that are broader to narrower, and maps that are narrower to broader. All right, so let's go to the next slide, please. Okay, so again, if you have Term Manager or if you have any other tool, maybe even if you have a normal browser in front of you, I'm just going to give you a few seconds so that you can try and map these terms. The first one, that number 3 that you see in brackets, that's basically the triage level, the CTAS level, just so you know. And so there is a lot of information in that one term. Abdominal pain, it's a moderate pain. The CTAS level is 3. The patient may have episodic vomiting and or fever. So how do you map that? So I don't know if that gave you enough time to try, but in the interest of time, I move on. So the point I wanted to make on this slide is about when you have multiple pieces in the source. So again, in this case, you see abdominal pain, moderate, episodic vomiting, fever. These are all different pieces. Sometimes they are attached to each other with and, sometimes with and/or, sometimes just or. And then what do we do with this? So if we are only considering mapping, because there are other options, maybe not suitable for this one. So for example, you can potentially add this to your extension. Maybe you can even ask Infoway to add this to the Canadian extension. I'm guessing this would not be a good candidate, and Infoway would not accept to add this because there is just too much information in one term. It's very specific, but again, not going there. Sometimes it might be the case that you may want to add that to an extension that you can use. But other than that, just as long as we are just considering the mapping, the choices that you would have would be limited. And in this particular case, we worked with the clinicians. They felt that the abdominal pain part is the most important part, and basically that's just what we chose as the target. Again, you can imagine there is a lot of information that will be lost, but that was the most important piece that we wanted to keep. Now let's try the other one, colonoscopy with esophagogastroduodenoscopy. So if you try to search for these, you will not find anything in this moment. Then what do you do? Again, there is one idea is to try and see which one is more important, similar to what we did with the one that's above. We chose abdominal pain and we said that's more important. But here, it may not be the case. Both of these pieces seem to be important piece of a procedure that was done, and we don't really want to lose that. So what do we do? Any ideas? So if you search for colonoscopy, for example, and you can see that on the right-hand side here as the second option, or the other, and just navigate through the hierarchy and go up, you will eventually get to a concept that is basically, let me read it for you. It's a gastrointestinal tract endoscopy. So that might be something that you may want to consider. That is apparent to both of these, and it captures both of these concepts. Yes, you will lose some specificity here with the term, but again, because it seems like you are doing a gastric tract endoscopy from both ends in this case, that might be a very appropriate term to consider. So I just wanted to show you another example and another approach that we take when we have multiple pieces. All right, so let's go to the next slide, please. Okay, so this is similar to what you saw before, but I have something else in mind to discuss here, and that is about one-to-many maps. So hysteroscopy with dilatation and curettage. If you try searching that, right, and just showing, you see the first one is dilatation and curettage. You don't have hysteroscopy, right? You see hysteroscopy a few terms down below. And then again, you would have to think whether you want to choose only one of these or whether you want to go up in the hierarchy and find a parent that is common to both of these. In this particular case, you may not even find a parent that is common to both of these. And so unless you maybe go very high in the hierarchy, to the procedure or something, at a very high level, to the point that it becomes actually useless and meaningless. And so one other trick that we might be able to use, depending on the way the source and target is structured, depending on the way the databases are structured and how the use cases are, is one-to-many maps. On the first slide, I told you that this is something that is is discouraged and we try to avoid, but it's just sometimes the reality. If the systems allow, we might consider this. And again, just wanted to say that might be an option sometime. So next slide, please. Okay, so this ties very closely with what I was showing you about the information model. And remember that term diabetes you had when it goes under different pieces or parts in the information model, it means different things. So this is a good example. So let's imagine you're trying to map conditions and you come across these two terms, hemodialysis and cataract surgery. How do you map these? I'm just going to give you a few seconds to think about it. Okay, so you can see on Jess's screen here, hemodialysis actually has a perfect match. However, that's in procedures domain. You can see that by the procedure in parentheses, the semantic tag on the term. So that's a procedure. We are mapping conditions. So what do we do? Is that an appropriate term? Maybe not, because basically hemodialysis implies that there was an action done for the patient. We need to understand what the clinician means, whoever enters this data, what do they mean when they put hemodialysis in the patient chart? And so we asked them, and what we were told was that what it really means is that the patient is dependent on hemodialysis. That's the reason it's documented under the condition of the patient. So if we search for that, then yes, you can see that dependence on hemodialysis. Now you can see that on top. We decided to map it to this one. Again, sometimes we need to not map to something that looks like an exact match and consider the meanings behind it. Cataract surgery is another good example. We asked, and what they told us was basically they were trying to document a history for the patient in the condition. So with that in mind, then we went and looked into the situation hierarchy for maps that would be more appropriate there. All right, so let's move on to the next slide, please. Okay, so the other thing I want to point out is, and again, this is similar to one of the examples with that abdominal pain that you saw, but the point that I want to raise here is different somehow. That's specifically about and/or. So you see this example here. One thing to note about and/or is that it really means an or logically. So and/or is just the same as logical or. And so when you're dealing with or in SNOMED, in terminology, it becomes a little tricky. The next slide, please. I'll explain through a few different slides here. So with and/or in SNOMED, you typically get into some concept modeling that is called an and/or diamond. So let me explain. So imagine these two circles. The one on the left is representing all fractures in the arm in which ulna is fractured. So ulna is one of the bones in your forearm. And then the circle on the right is all the fractures in which radius is fractured. So that's the other bone. Now, if you want to look for patients who have both ulna and radius fracture, then obviously you look for that middle part, the common part. And that represents all fractures in the arm in which both radius and ulna is fractured, right? So next slide, please. So now if you're looking for fractures of radius or ulna, and instead of or, you can also say and/or ulna, again, that's the same thing. If you're looking for fractures of radius or ulna, this is basically what you're looking for. So this blue area is the area of your interest. Next slide, please. If you're looking for one of those in particular, so ulna or radius, and you don't care about the other one, so you're interested in fractures of ulna, you don't care whether or not the radius is fractured. Then basically you would be looking at one circle only, and depending on whether it's left or right, that would be the circle that you will look at. Next slide, please. Okay, so that again, that middle part here between the part that is common between these two circles is the part that you would want to consider if you're looking for both. So if you want to see the fractures of radius and ulna at the same time, then that middle part is the one that you would consider. So again, thinking about this, the last two slides, you see that the or was the biggest area. The one that had only one bone was the smaller, and the and has the smallest of all areas, right? So that basically shows you the specificity. In a hierarchy, in a terminology, as you move up and go towards the parent, your area gets bigger and wider and broader. As you move down to our children, your area gets smaller and more specific, right? So next slide, please. And this is exactly how it's represented in the terminology. So at the bottom, you see fracture of both radius and ulna. Those arrows represent the parent-child relationship. So that is a child, the one at the bottom is the child, to both concepts of fracture of ulna and fracture of radius. And those would be, both of them would be children of fracture of radius and or ulna, right? So, and then what that forms is basically a diamond, which is called an and/or diamond. And you very typically see that in SNOMED. And this is something you should consider when you're trying to map. Are you talking about and, are you talking about or? And that would be a different mapping. So next slide, please. One thing to note is and does not always mean and, and that's sometimes very confusing. So in ICD, for example, ICD is a classification, international classification of diseases, and really means or. And here is the reason. Imagine this bucket, this red bucket. Imagine that is your group, your class. So you have a group or a category called endocrine, nutritional, and metabolic diseases, right? So that's the name of your class. Then these beads, the colored beads, would be the different patients, the different conditions that you would decide to put into that bucket. So for example, if you're coding the chart of the patient who has endocrine disease, let's say that's the purple one, you put that in the bucket. If you have a patient with nutritional disease, let's say that's the orange one, you put that one also in the bucket, and so on, right? So then your bucket will consist of a number of different types of beads. Now, from the perspective of the bucket, if you ask the bucket, what do you have inside? Then the bucket is going to say, I have purple and orange and gold and so on, right? So from the perspective of the bucket, it's an and. From the perspective of the bead, it's an or. So if you look at one bead, it's either purple or orange or gold, right? So now you're talking about or. And that's important to consider because usually when you're mapping, you're dealing with clinical data And clinical data is typically about one patient. So you have the data at the patient level. Again, not always, but usually in your mapping, you have data that is at the patient level and chart level. So for that reason, you are dealing with, when you have classifications like this, you are dealing with OR. So that's something to consider. Next slide, please. Okay, so the other thing I wanted to mention is mapping guidelines document. So what we do always when we have a mapping project, and I would strongly encourage you to do the same, is to have a document that is called your guidelines document. It is a living document. It is going to evolve through your mapping, and as you identify patterns in your data, you will add to it and you will make it richer and richer. What it is that it basically makes sure, the intention is to make sure that all the users, all the mappers, and all the users of the map eventually, and whoever is going to review and approve the map, agree on a set of rules. So, for example, you specify the use cases. So this is how the map is going to be used. This is the target that we choose. These are the data pre-processing steps that we took. And if you want to redo that, we'll do exactly the same thing. These are the mapping rules that we have. So some of the mapping rules, for example, we saw some examples before. For example, to what extent do you allow broader to narrower map? And, under what conditions? Who would have to approve that? Do you, for example, do you do a one-to-many map or not? When you see some patterns with, let's say, the triage number in the term, what do you want to do with it? Sometimes depending on the triage number, you may want to map it differently. If the triage number is high, for example, maybe you want to consider acute in the term, or things like that. Again, once you identify patterns and see how your data looks, then you can decide on these. There is always that temptation that I want to make this document perfect and then start my mapping just to avoid duplication of effort. In my experience, it never happens. You can never ever do that perfect from the beginning, because as I said, once you start working with your data and once you start mapping, sometimes 2 months, 3 months into the project, then you see some patterns and then you want to make modifications, and that's perfectly fine. Next slide, please. All right, so I think I touched on this very quickly, but again, just to recap. So there are some pros, some advantages with mapping. With mapping, you achieve a standardization, you achieve normalization, interoperability, you allow analytics and all that. But also, always keep that in mind that with mapping, you lose information. You are going to have changes in the granularity. You will be dependent on the level of granularity in your target as opposed to in your source. So make sure that the benefits outweigh. And also, if you can, if there is the opportunity, try to standardize from the beginning before you even work or create your local term. Sometimes people create local terms and then decide to map. If you can, try to standardize them from the beginning. That saves you a lot of time and headache later on. And one thing to note is mapping is always a one-way road. You can't go back on the arrow of the map because of the changes or differences in the granularity that you saw. You can't really go back on a map. So once you map, you can't go back, and that's an important one. Next slide, please. So I think this is the last slide. So going through this very quickly, what makes a good map, in my opinion, my experience, is it should support use cases and meet business needs. We talked about it before, and I think this is obvious. Another thing is consistency. There is a saying that, consistency is more important than correctness. Sometimes that's really the case. You want to be consistent. If you have a rule, stick to it. If you think that's a bad rule or you want to change it, then change it for everything. And again, try to be consistent. Collaboration is key. Usually a mapping effort is done by more than one person. Also there is another person or team that would review and approve. So it's important to make sure that the relationships are established, the rules and the guidelines are established, and it's clear, and the workflow is also established. So who starts, then who gets the map after that? How do you divide? How do you make sure you don't step on each other's toes? Those would be very important considerations too, because it's going to be a multi-person and multi-month sometimes, long-term project, and it's just very easy to get into pitfalls, and you want to avoid them as much as you can. And the last thing to say is that mapping is not necessarily always results into one target. So if you give a source term to multiple mappers, if that's a tough one, they may end up mapping it differently. And that's not always a bad thing. Sometimes both maps, or even 3 maps, are perfectly acceptable maps. There is no advantage one way or the other. And that's different than wrong map. So you want to make sure you don't do anything incorrectly. You also, as I said before, you also want to make sure you are consistent as much as you can. But at the end of the day, also acknowledge that sometimes there is more than one answer to one question, and that's just the reality. All right, with that, we are right on the hour now. So back to you, Anil.
Okay, thank you, Shapur. Are there any questions that you'd like to ask? We can run over a few minutes. Okay, well, if you can't think of any questions right now, you can always post questions on the Health Terminologies Forum, or forward them to standards at inforoute.ca, and we will forward them on to Jessica and Shapiro. I'd like to take this moment to thank you both for a wonderful series and presentations, and talk to you in the new year later. Okay.
Thanks so much, everyone.
Okay. Bye.
Thank you.